We're really proud to have you.
Yeah.
Chris Eidhof.
Hello. Thank you for the nice introduction. Let's, before we continue with anything, let's give a really big hand for the organizers. They put in so much work. They make it look easy, but it's really hard to put on a great conference, and they're doing a great job, so yeah. Okay, we're going to do live coding today. I'll run it. Can you, at the back, can you see over the heads and see this line, or do I need to make it higher? You can see it? Awesome. Cool. So, I made this little app. You can maybe not read it in the back, the text in the app, but that's not very important. So this is a flight app, and it has these labels, and it has this little airplane icon, and it has more labels. And if you build this using auto layouts, you almost have to build this using auto layout actually these days, because there are so many things to keep in mind, right? Like we have the size of the device, and different devices have different point widths, as we all know. Then we have things like rotation, and of course this works with auto layouts. But there's more. So let's go to the accessibility inspector. We should really be making sure. Oh, let's try it again. We should be making sure that everything works for dynamic type as well. So if you don't know the accessibility inspector, you can go here, select the simulator, select the settings, and here you can change the things for dynamic type. So you can make things smaller. And of course, this works with auto layout. If you set up your labels correctly, this works. So we can make things a little bigger. And as we get bigger and bigger, it just barely fits, so we're lucky. Let's change a little bit. So if we don't have a German locale, things get even bigger, which is sort of counterintuitive. But now we can see that it doesn't fit anymore. If we go a little bit smaller, everything fits, but we can see that if we go one step bigger, the text doesn't fit anymore. And so what happens in this case is I hide the airplane icon. And let's go back to the defaults. So it's another thing to keep in mind. You have the device size, you have the rotation, you have things like multitasking you need to keep in mind, you have dynamic type, you have the locale. And hopefully sometime soon, when we can run these apps on the Mac, we'll have stuff like this as well. We can dynamically resize our containers, right, or devices. So what happens here is we make it smaller, 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 and now we want the airplane icon to disappear. So it disappears. And we really also, if we make it even smaller still, let's say somebody has a very large font size, we want this other thing to be on the next line. So that happens automatically as well. And the question is how to achieve this. I don't know an easy way to do this with auto layout or basically manual layout or something like that. So we wrote a library for this, and that's what I'm going to show today. So let's go back to the normal size, and I'll actually delete all the layout code we have in this app, and we'll start with an empty layout. Delete this. So here's all the layout code, white boxes, airplane, choices, layout. And we'll start with an empty layout. And if we run it now, we should have an empty view. So far, not very exciting. So empty view, it works, great. Thank you. So let's look into this layout struct. So basically, there are 4 cases in the layout struct. Empty is the easiest one. Then we have an element, which is an element on a line. So that's important to keep in mind. So it's an element with a width and vertical alignment, and then the rest of the layout. Then we have the new line, which is basically a line break and with some vertical space. And we have a choice, which is either the left or the right layout. And that's really all there is to the library, except for how it computes the layouts. And then there are some nice combinators to work with. So the first thing we'll do is create the from label. So we create a UI label. I made a convenience initializer to save some typing. So we can say from caption 1. And to turn this into a layout, because this type is UI label, we can call .layout. It's a method. It's very simple, the implementation. It just wraps something in the element case. Okay, so we can do it for the code. So let's create a text with, I have this sample data, and it has a destination airport and an origin. So I use the origin, and then we use the code. And for the size, we use title 1, and we'll lay this out as well. And then finally, we want the time. So this is a URL label again, text, sample, origin.time. And of course, we cannot really format or display an NSDate, so we'll use a formatter. And then we'll say string from origin.time. And then we want caption 1 as well, and lay this out. And to put the things below each other, we can, oh, I made some mistake. Yeah. And to put this into a layout, we can put them in an array. So we can say from code and time, and then put them vertically below each other. So vertical. So let's run this and see if this does what we hope it does. Well, the build succeeds. That's something. Okay, so this is what we expected. Now, the next thing we want to do is display the destination as well. And so we can move this code to an extension on airport. So let's actually delete it here and write it as an extension on airport, layout, and it returns the layout, and we paste this in. This is a return. And now, of course, this sample.origin should be self.code, and likewise over here. And this is a parameter we need to pass in. So let's call it title, string. And then over here, we can say that layout equals sample origin.layout, paste in the title, the label. And if we run it, we should have exactly the same thing. So not very exciting yet. Okay, same thing. So to put the other thing below is now easy. We know how to do this. So we can say sample.destination.layout title 2. And then we say .vertical. And if we run this, we should have the two things below each other. So easy enough. You can do this with stack views, much easier. Now for the exciting part. Let's try to put the two things next to each other. So you might have guessed that there's also something called horizontal. And this will work, but not quite. The result will be quite unexpected. So let's see if you can understand why this is. So what happens here? So we have the from, and then we have the label over here, and then we have the time, and then directly next to that is to. So that's the next label. So what's happening is the vertical and the horizontal combinators, they create these 4 cases, right, in the enum. So we have an element and a new line, an element and a new line, and then an element. And because we use horizontal, it puts the next element at the last line. So it puts the two elements on the same line, and then a new line, and then an element and a new line, and so on. So that's not really what we want. So we do have this line-based algorithm, and the solution in this case is to put these first three elements in a box, put that box on the line, and likewise for the second 3 elements. So we can do this. We can say inline box and inline box. And now it should work as expected. So that puts the 2 boxes on a single line. Okay, cool. Just let's write it a little shorter. We'll move the inline box into our extension over here, and then we can write this shorter. I like short code. I like functional programming. If it fits on a single line, even better. So now we have the same thing, and it works. And we also want some space in between. And we can do that. So we can say layout.space, and the space has a width. So we can say width dot. And then we have 3 possibilities: absolute, based on contents, or flexible. And we'll use flexible. We want at least 10 points. Actually, we don't need this, and we don't need this. We do need a comma. So let's run it, and now hopefully we have flexible space in between. Okay, so if we resize the container, it works. Stuff like dynamic type also still works. This doesn't look quite nice, so we want this little airplane in between just to fill up the empty space a little bit. So we want something like airplane and then more space. And to create the airplane, we'll do the same thing as before. We'll create a label and use the same thing, so we can actually do a trick. Let's write airplane. Who needs images, right? We'll use title 1. And there's actually a text color that we can use, dark gray, and it looks a little bit nicer. And we'll lay this thing out. So now if we run it, we should have the airplane in between with flexible space on either side. So that's quite nice, but not really. The airplane should be centered vertically. And this layout method that we use has default parameters. So let's try that again. Let's try layout, and we have a width and a vertical alignment. So the width we can actually leave off. We don't need that. Let's just go for the vertical alignments and do center. And now it should look nice. Okay, here we go. So we can still resize it. Everything works. This pattern is really common when you do a horizontal layout where you have an element, space, element, and so on. So there's actually an easier way to do that. So we can write this, and then we can say horizontal and use a min space of 10. By default, it's nil, and it doesn't put in any spaces. So that's a little shorter, and it still works the same way. And now let's start doing the more exciting stuff. So this is the origin. I'll pull it out into a variable. And the destination. And now, well, I like the functional programming, so I can put it on a single line. Functional programmers love this. So how do we express this concept of, well, we want the airplane to disappear? So it's actually really easy in this library. You say or, and then you put in a different layout. So we can say, for example, origin destination.horizontal, min spacing 10. And that's really all there is to it. So the way the library works is it tries to compute the frames of the line, and it knows what the width of the container is. If you have an or expression or a choice, it tries to render the first one, but if that doesn't fit, it always picks the second one. So here it tries to render the first one, it fits, it's fine. So we can resize, and as it becomes smaller, the airplane disappears. And as we have space again, the airplane appears. And this works also with the accessibility inspector. So as we increase the font size, we can see that the airplane disappears automatically. So that's really useful. The other thing we can do is add this vertical layout. So here we can say, well, we have the horizontal, or we have origin and destination dot vertical. And let's see what the space looks like. The vertical space, we want 10 points as well. So now we can run this. Let's restore to the defaults. So we have our labels, we can resize it, and as less space becomes available, the airplane disappears. And then we want the minimum of 10 point spacing. If that's not available anymore, it just moves below. So I imagine this is very useful for things like Mac apps once we build those, but also to deal with all these different devices. That's why my talk is called The Next 700 Devices. You just cannot keep this combination of explosions in your head anymore, right? Like all the different things you have to keep in mind. So the next thing we want to do is put a little nice white box around it. We had that in the beginning. There was this nice box with rounded corners. And so let me refactor this a little bit. I'll call this choices, and then say layout equals choices. We want to put the box around this thing, but also around this thing and around the third option. And the cool thing is that this layout library doesn't mind at which level the choice is. If it's very deep inside your layout or at the top level, you can do that however you want. So we can just say choices.inlineBox. And, well, let's use the default parameters, so inlineBox, with a wrapper. So we'll leave off the width and the vertical alignment, and just use the wrapper. And we want to have a white box. So this is the most difficult part of the presentation. That white box equals UI view, white box dot background color. You know this stuff. White box dot layer, corner radius equals 5. Okay, so this almost does what we want, but not quite. So it's very tiny. And the reason is because the inline box, it has a width, and the width is a default argument. And by default, the width is based on the contents of the inline box. So here in this case, we have an inline box around these 3 labels, and so the inline box takes that width. And here it's the same thing. So we want a different width. We can actually look into this inline box method, and we can see that the default width is based on contents. And what we want is something we've seen before. So we want to say width is flexible. Oh, let's do it like this. Flexible. And we don't really care about the minimum value. So now if we run it, we should have a white box around the entire thing, with the choices sort of embedded inside the box. So if we resize, we can see that that still works, and it still moves below. And yeah, things like rotation work. If we have a different device with a smaller width or a larger width, that will work. If people resize the device or change the locale or change their dynamic type, it will just work. And yeah, this is basically the part that I wanted to show, like how you build stuff with the library. When I demoed this to the organizers, they told me, yeah, we will also want to see how this works under the hood. And that I cannot show in 20 minutes. We have, I think, already 6 Swift Talks episodes ready about this. So it takes a little bit longer than 20 minutes. But I will show a little bit and sort of give you the essentials. So let's open up our layouts, Enum. So we talked about this before. There's 4 cases: element, new line, choice, and empty. So the element has an element, then a width and a vertical alignment, and the rest of the layout. And likewise for the new line, a space, and the rest of the layout. And with choice, we now know that it always tries to pick this first layout, and if it doesn't fit, then it picks the other one. And the core of the algorithm is here. Compute lines takes a layout and computes all the lines, and then there are no choices anymore. And it does that given a certain container width. And then it applies all the computed lines to the actual view, so it sets the frames. We need to do this in 2 steps because we have to compute, for example, the flexible width. The other enums that are there are the vertical alignment, very simple, an element, which is either a view, a space, or an inline box, and the width. And that's basically all you need to know about the interface. Let's look at the algorithm a little bit. It works by using this UIKit method called sizeThatFits. So this is on almost any UI view. It doesn't use auto layout. It really looks at sizeThatFits. So this works with all kinds of views, not just with labels. And another maybe an interesting case is if we scroll down a little bit, we'll find the choice. So this is computing the lines. And here we have the choice case. So what happens is it tries to call compute lines on the first option in the choice. And if that returns nil, it chooses the second option. So it will return nil when it doesn't fit anymore. And yeah, the rest is mainly a lot of layout math. And yeah, that's basically all there is to it. I hope you will find this useful. It'll be on Swift Talk sometime soon, and open source also sometime soon. And yeah, now I'm happy to take any questions. Thank you.
Thank you, Chris. Thank you very much. Thank you.
Hope I don't sit on the mic.
You're just the only guy crazy enough to do live coding in a conference. And I want to thank you for that, because it's always really interesting. Do you think this is going to be like production ready soon?
Yeah, I think so.
Would you put that in a real app?
The big thing with this library is it does the line-based algorithm. So that means it can do some things really well with the choice and stuff, but there is a lot of things that it cannot do. So it's not a solution for everything, but I think we can make whatever we have work well. And the computation is really fast. It's linear. It just basically loops through that sort of linked list of views and lines. And yeah, so we're using it, and I think once we release it and other people look at it, we'll find some more bugs, and then we can call it production ready.
Okay, and I saw that when you were resizing to very small size, we had some animations like for free. It was really nice. And so, do you think we can mix that with auto layout parts of the app and also with the nib?
Yeah, absolutely. So the resizing, the little red thing in the corner, that's done with auto layout. So it just changes the size of the frame, and the red boxes, for example, attached with auto layout to the container. And if you drag on it, it changes the size of the container. And inside the container, we used the width of the frame to compute the layout.
Okay.
Interesting.
Nice. Okay. And what about performance?
Yeah, that's always a good question. In my testing, it's a lot faster than auto layout. But of course, if you have a lot of choices, you can always make it so that it becomes slow. But it just loops linearly. So we have the 4 cases. For the element, it can just compute the frame. For the new line, it can compute whatever it needs to do linearly. Then if we have the choice, we have to, worst case, compute everything in the left branch, and at the end we notice it doesn't fit, and then we continue with the right branch. So it's the complexity is O(n), where n is the number of elements in the tree.
And can you tell us more about this the choice? Like, is it always based on the size, or can you define that you will?
It's only based on the size. So I wanted to keep it simple. It only checks, does the left thing fit? If not, choose the right thing. So it always has a default.
And what about hacking the system? Like, if you need to do something that is actually not planned, is it easy to enter the code or to, like, I don't know, from outside modify the behavior?
Well, it depends how well you know the code, I think. The code is currently 350 lines, the library, so it's not very big.
The whole library?
Yeah. You can. When we practiced for SwiftTalk, we wrote it in a day. So we built it a few times, and then we practiced, and in one day we could come up with what we have here after practicing.
Yeah, sure.
Yeah, that's amazing. And but I also like that at the beginning you showed us like the code of one method of the library. It was like simple and kind of reassuring. Like we can actually look at the code. That's kind of nice.
Yeah, absolutely.
I have two more questions. When you develop things like that one, do you use like some special tool to iterate rapidly, or you just recompile every time you're on the simulator, or you have like a homemade hot reload solution?
No, I just compile it. It's very small.
Okay.
I don't have many things in there. At home, I have an iMac, not even a Pro, but it's really nice and fast, and that works.
Okay,
yeah.
Nice.
And like I was afraid of asking a question like, why not trying or doing the live coding in Playground?
Yeah, well, for this, I think it's a little easier with the resizing. I always switch between Playgrounds. I will do everything in Playgrounds for half a year, and then at some point I stop using Playgrounds.
Really? Like as a whole?
Yeah, now they changed everything again, so I need to get used to that.
And so when you have, so it's just a question which is not directly related to our talk, but when you have such a small library, what's your suggestion? I mean, just integrate the code, or maybe have it as a dependency, as a pod, or?
Yeah, well, in the state it is now. I mean, if anybody wants the library today and wants to use it in their app, they can come to me and I'll put it on GitHub somewhere hidden, or sort of not in plain sight, because I don't think it's a bad idea. I don't think it's a good idea to use it as a dependency because it will completely change probably at some point soon.
What is missing? Like, what will you change?
So one thing, in a previous prototype, I added this thing that you could say scroll if needed at the end of a layout. So it would compute a horizontal layout, and if it's and a vertical layout, and if the vertical doesn't fit, it puts a scroll view around it. Another thing that I added is setting properties for different layouts. So you might want to say, well, I want to have these things horizontally, or the same views, but with different properties set. So let's say a slightly smaller font, also horizontally. So stuff like that. And because I don't really know exactly what's missing yet, it's a bit hard to...
That was actually my next question, like what, because people would actually think, like, is it really usable for a real app, a real problem? But
I think it is. I mean, in the end, it's just the layout, right? It's the same UI labels, the same UI image views, and UI buttons you can put in. You get all the accessibility from UIKit. There's nothing like that. It only sets the frames for you. It's just a complicated way to set the frames. Yeah.
And later on, when you think it's finalized, do you think such a short dependency will be better be used as an external dependency, like so as a pod, or integrated directly via source?
Yeah, I don't know exactly. So I don't like taking on too many dependencies myself. So if somebody else would have written this, I would be a little bit scary or a little bit scared. I don't know. Like, it depends on what you want to do. If you want to hack with it, I would say just copy paste the source code and own it, and then you own the code and add new features, and maybe you can look at what changes. But I can also imagine that this becomes a library that, you know, after a few iterations, it stabilizes. So I don't want this to do everything. I mean, auto layout is awesome, and we should keep using that. But for some things, like as we saw, this can be much nicer for a small subset of all the problems. So maybe we can just solve that subset really well and then sort of stabilize the library. I think that would be kind of nice.
Okay.
Okay, thank you very much.
Thank you very much.
Thank you for your talk.
Thank you.